Simplify the following expression. Well, there's a lot of numbers and variables, and we're taking a cube root of something, which often confuses students. Let's look at a couple side examples here. If I were taking the cube root of x cubed, well, the cube root of x cubed, or any number cubed, is simply that number or variable. That would result in simply x. But what if I was taking the cube root of x to the sixth, which is the variable in this case? Well, I can think of x to the sixth as the cube root of x cubed times x cubed. That would result in x times x, or x squared. I could also think of x to the sixth as the cube root of x squared cubed, remembering that power to a power I multiply. Therefore, if I divided 6 by 3, I'd get my x squared. This also results in simply x squared. Well, now let's look at our problem. So I'm going to rewrite each of these pieces as something to the third power. A negative 125 could be rewritten as negative 5 to the third power. X to the sixth, as we know, could be rewritten as x squared to the third power. Y to the fourth? Well, this one's a little bit more difficult. Looking at my first example, I could look at this as a y cubed. But if I have 3 of them here and I need 4, I'm going to have an extra y. And finally, z to the 15th, dividing that by 3, I have z to the 5th power, again, cubed. All of this, I am still taking a cube root. While now anything to the third power, I will be able to pull out. Therefore, I have a negative 5, an x squared, a y, I still have one on the inside, we'll get back to that, and a z to the 5th power. Now what's left on the inside is simply 1y. And this is my final answer, negative 5x squared y z to the 5th times the cube root of y.